and welcome to this part of One Man and His Whiteboard. Today we continue in our conversation of IP subnets, taking it one step further, and we're on part 5, calculating subnets continued. This time we're going to calculate a subnet using a non-byte boundary. So as per our previous example, we're going to go through the same process, only this time we are talking about an IP address of 172.16.25.17, and we're going to use a mask of 255.255.248.0. It's a non-byte boundary mask. It's not a 0, it's not a 255. Same as before, we're going to calculate the subnet address, calculate the host portion, calculate the first and last host numbers, calculate the broadcast mask, and then identify the next subnet. Same as we did last time. I'm going to go through this process. I'll leave this on the screen a little bit for you to all have a look at it. Obviously, you can pause. The beauty of video, you can pause, go back and watch it again. As before, determine the IP address class using note number 1. The IP address of the first byte is in between 128 and 192, therefore it's a class B. Convert the IP address to binary using the layout in note number 2. We see that here. As always, I've left a little gap in the middle to break them out into 2 lots of 4 bits. Always try and line up the bits, it makes life a lot easier. Now convert the network mask into binary, and then convert the class mask from note number 3. So a class B as a mask, a default network mask of 255.255.0.0. Now, as before, line up the binary we got thus far on a sheet of paper. Write down the IP address, the network mask, and the class mask. Look at where the network mask and the class mask differs. Highlight it. Here, I've surrounded it with a yellow box, and I've converted it into red. Everything to the left of this highlight is the network, the class network. What's highlighted is the subnet. Everything to the right is the host field. Now note, the host field includes 3 bits from the 3rd byte this time. Now you write down the number from the subnet above it, then you zero out any host bits. Convert that to decimal and you can see that subnet is 24. So the class network is 172.16, the subnet is 24, the host, now the host gets a bit weird now. I use the format like this, the host is +1.17, because you have to add the 1 onto the 24, the host is 25.17, but 24 identifies the subnet, remember. So I've used the plus here to identify, you add this value onto the 24 to complete the host. As before, write down the IP address up to and including the end of the subnet field 4 times. Write all zeros in the host field. Add 1 to it. Jump down to line 4. Write all 1s in the host field. Subtract 1 from it. Convert these numbers to decimal, and what you have on line 1 is the subnet address and the first host on that subnet. On line 4 you have the broadcast address, and on line 3 you have the last host. And notice that this method automatically takes into account these 3 extra bits that you have in the middle. Simple, right? You'll practice this a lot. As before, to calculate the next subnet address, write down line 1 again and look at the highlighted subnet. Add 1 to the subnet number, not the byte, not the subnet and host, just the subnet number. Now that will be 0001, 1 plus 1 becomes 00100. Convert to the decimal, and it's 172.16.32.0 is the next subnet address. Another quick shortcut for you, if you were to add 1 to this broadcast address, all the 1s will ripple over to be 0000000000001, and that of course will be 32, because the next number after this is 32. So you could have just added 1 to the broadcast address as well, but this method is a lot easier and simpler to do. So 172.16.32.0 is the next subnet after 172.16.24.0. And as I mentioned before, our shortcut, if you look at the mask, we have 5 1s in the mask, and the 5 1s take us as far as the 8-bit position. So we now know that all the networks go up in 8s. So the next subnet after 24 is 32. The next subnet is 32 plus 8, 40. The next subnet is 48, and so on. So as we discussed in the last section, once you've done this calculation, we can now take a look at the subnet field, and we can see that we have 5 bits in the subnet field. Well, 5 bits give us 32 different number combinations, different decimal combinations. So remember, you take 2 off, so we can have 30 networks using 5 bits or a 248 mask. However, we can have 7 times 256 minus 2 hosts. So a nice easy way to calculate the number of subnets and the number of hosts you can have is by simply counting up the number of bits. 5 bits for the subnet, 2 to the power of 532 minus 2. 11 bits for the host, 2 to the power of 11. Effectively, it's 2 to the power of 3, 7, multiplied by 2 to the power of 8, 256. 7 times 256, don't forget to take the 2 off at the end. Okay, I hope you've had fun with our advanced subnet calculations. I will see you next time.